Hi, I'm Yusuf Abdullahi from statisticassignmentexpert.com. I want to share you an assignment based on t-test and ANOVA using Excel. Let me introduce you to my data first. I have my data here that contains six variables and 300 observations. So I have ID number of the subject, male 0 for female, 1 for male. Race, I have 4 different type of races. Treat, 0 for control, 1 for treatment. And then pre-treatment BMI and post-treatment BMI. So I want to answer 3 major research questions. So I want to answer if post-treatment BMI score is significantly lower than pre-treatment BMI scores. I want to know if BMI is significantly different between treatment and control. I want to know if BMI is significantly different across race. So let me start from here. In this video, I will tackle the first question and I will continue with other questions in subsequent videos. So we want to know if post-treatment BMI score is significantly lower than treatment BMI scores, and we have set our null hypothesis as this: post-treatment BMI score is the same as pre-treatment BMI scores, and the alternative is that post-treatment BMI score is significantly lower than pre-treatment BMI scores. So taking a look at our data sets, we see that the pre-BMI and post-BMI is collected for the same observations for the same subject ID. So which means this is a repeated measures, or we call it paired sample. So then we are using paired sample t-test for it. But we can, before the test, we can check on the summary statistics by clicking on data analysis. If you don't have you first of all go to data, then you click on data analysis. So if you don't have data analysis, you can go to your Microsoft window, then Excel options, then from Excel option click on add-ins. From add-ins, go to manage add-ins, then you will see analysis to pack. It has to be marked. If it is not marked, just mark it and press OK. You will see your data analysis stuff here. Then you can go from it and click on descriptive statistics. Then we highlight the two column. So this is arranged by columns, and then we click on label in the first row because the first row contains variable name. Then if we want our output to be displayed on this sheet, we click on output range. Otherwise we click on new worksheet. So if we press OK, you see your summary statistics. So this is the mean. So we see the average BMI is greater in pre than in post. So this difference we want to check, is there any significant difference? Are they significant? Is the difference significant such that we can say that PMI has significantly reduced at post-treatment period than in pre-treatment period? So that is what we do with paired sample t-test. So we go to paired sample t-test. We click on this pair 2 sample formulas. Then the variable 1 range will be our BMI pre. Then we go to variable 2 range, we go to post BMI, post BMI, then the hypothesized mean difference. So the null hypothesis will tell us what we are putting here. So you know that our null hypothesis is S treatment equals to S post treatment. If you take post treatment to the other side, you have 0. That is, pre-treatment minus post treatment is 0. Then it means that we are putting 0 in our hypothesized mean difference. Then we are using alpha level of 5%. Then, so if you want our result in new worksheet we press, when we want it in a range of output, we put it there. So we go to new worksheet, then we click on OK. So this is the result that is displayed for us. So we can see that the mean is 25.79, 25.52, which is the same thing as what we have here. Then this is the variance observation. We have 300 observation. Then this is the correlation. For paired sample, we expect the correlation to be high because we expect the behavior to be the same. Then or we expect the behavior to be similar. So this is the hypothesized value. So that's the hypothesized mean difference. And then the degree of freedom is n-1, that's 300 minus 1. We have 299. So this is the test statistics. So this t-statistic is 1.47. Then the probability is for one tail test is 0.07. And then this is the critical value, that is the tabulated value for a one tail, 1.64. And then this is the probability for two tail and the critical value for two tail. So one tail or two tail, what are we using? We go back to our hypothesis. So we are going to use H1 to alternative hypothesis to determine this. We say post-treatment BMI score is significantly lower than pre-treatment BMI score. So we say S post-treatment less than X pre-treatment. So if we take this to the other side, we see that, and rearrange, we see that S pre-treatment minus S post-treatment is greater than 0. So since we have is greater than, then it is directional. So we are going to use our one tail result. So this is greater than 0, and if this is greater than 0, sorry, this is greater than 0.05, our significant level, and if these are greater than 0.05, it means that we cannot reject our null hypothesis. So we cannot reject the null hypothesis that post-treatment BMI score is the same as pre-treatment BMI score. So we see that there has not been significant changes in BMI at post-treatment compared to what we have in pre-treatment. In subsequent videos, I will continue with the second question. That if BMI is significantly different between treatment and control. So for any assistance on statistic assignment, email to support@statisticassignmentexperts.com. Thank you.